Hi, I'm Harshit Ramesh, and my project is with building a low-cost pipeline inspection robot that makes pipe images easier to understand. There are a lot of things that we take for granted every single day, and pipelines are one of them. They carry things like gas, water, and waste, but inspecting them and making sure they're ready for our use is not easy. This can be made hard because they're resource expensive and time-consuming to inspect. That's what made me interested in finding a simpler and safer way to inspect them. This research matters because pipeline failures can have serious local impacts. After the gas line explosion near Hayward in December 2025 injured 6 people and damaged several of the nearby buildings, it became clearer to me how important infrastructure safety is. My project aims to improve part of this problem by making inspection data easier to understand and hopefully helping people and the community. One big challenge is that when a camera is inside a pipe, the image looks circular. That makes the view harder to interpret because objects near the edges look compressed and distorted. Small cracks or features can be harder to notice. My idea was to take that circular image and unwrap it into a flat rectangular map so that it becomes much easier to read. The process has a few steps. First, the robot captures images from inside the pipe. Then, you estimate the center of the pipe using the image. After that, you process the image to unwrap the circular view into a panoramic rectangular view. Then, you can stitch together multiple frames over time so that your result looks more like a continuous map rather than a collection of random images which you have to analyze. The goal is to turn raw footage into something that's more useful for inspections. The robot itself is designed to stay compact and affordable. It uses a small chassis, motors, a wired camera, built-in lighting, and basic sensing. I tested this system using raw RGB frames from the robot camera and also using open source datasets. The results of the process were quite encouraging. Under controlled lighting, the center detection stayed within about a 5% error of the true center. More importantly, the unwrapped map made the pipe wall much easier to see and interpret than the original circular view. It created a stable, flat surface, which means that features are easier to locate and compare over time. Overall, this project shows that a low-cost robot combined with a computer vision can make pipeline inspection more practical and more accessible. Instead of relying on normal footage, we can generate clear and ready-to-use maps that help document pipeline conditions better. However, one limitation that I'm still facing is that lighting still matters a lot. With shadows or too much glare, the center detection can be skewed. Something I'm right now working on is building better lighting control, better center estimation, and helping create a more seamless map with better stitching with the code. Thank you for listening.